Good day. I'm Erickson Dimonahan, and we will be discussing the network components and the common types of network. For our outline, we will be discussing introduction to computer networks, the network components, common types of networks, and reliable networks. After today's lecture, you will be able to explain how host and network devices are used, explain how LANs and WANs interconnect to the internet, and describe the four basic requirements of a reliable network. The world right now is the world without boundaries. We have built human communities, human network, and global communities. A network is a group of computers or a group of smaller networks that are connected to each other by various means so that they may communicate with each other. The internet is the largest network in the world. Networks are able to share one resource, such as a printer, for numerous computers. This allows many individual computers to access a single network. This saves money and space for the organization. Basically, we have the hosts. Every computer on a network is called a host or end device. Servers are computers that provide information to end devices. And we have different types of servers. We have email servers, web servers, and file servers. Email servers run email server software, and clients use client software to access this email. Web servers, on the other hand, are used to access web pages. File servers, corporates or stores corporate and user files. Clients are computers that send requests to the servers to retrieve information, a web page from a web server, and email from an email server. We also have the peer to peer communication. On a peer to peer communication, there is no client and there is no server. Both devices are of the same level. This type of network design is only recommended for very small networks. The advantages is it is easy to set up, less complex, lower cost, and it's used for simple tasks such as transferring files and sharing printers. The disadvantages is that it has no centralized administration because there is no client and no server. It is not as secure compared to a client server setup, it's not scalable, and has a slower performance. For the network components, first we have what you call the end devices. An end device is where a message originates from or where it is received. Data originates with an end device, it flows through the network or through the intermediary devices and arrives at an end device. Some examples of end devices are computers, printers, servers, and your mobile phones. The next network component is your intermediary network devices. This interconnects end devices. Some of the examples of intermediary network devices are switches, wireless access points, routers, and firewalls. Management of data as it flows through a network is also the role of an intermediary device, including the following: regenerate and retransmit data signals, maintain information about what pathways exist in the network, and notify other devices of errors and communication failures. The next component is the network media. Communication across a network is carried through a medium which allows a message to travel from source to destination. And we have different media types: metal wires within cables, which carries electrical impulses; glass or plastic fiber within cables or fiber optic cables, which uses pulses of light to transfer information, and wireless transmission, which uses modulation of specific frequencies of electromagnetic waves, which we use for wireless access or mobile devices. Networks are represented by diagrams. Since you will be using packet tracer as simulation, we have the following diagrams to identify or represent devices within the network. We have end devices, such as desktop computers, laptops, wireless tablet, IP phones, intermediary devices or wireless routers, LAN switch, routers, and firewall appliances. Some of the important terms to know are the network interface card, which connects your network or your end device to a network, physical port, and interfaces. Oftentimes, the terms port and interface are used interchangeably. We have two topology diagrams to represent our network. The first one is physical topology diagram, which illustrates the physical location of intermediary devices and cable installation. Logical topology diagrams, on the other hand, illustrates devices' ports and addressing scheme of the network. For the common types of networks, there are networks according to sizes. The first one are small home networks. This connects a few computers to each other and the internet. One example is our network when we are still working from home. Small office and home office enables computer within a home or remote office to connect to a corporate network. This is also a setup for working from home while we use virtual private networks or VPN. Medium to large networks, on the other hand, are located at many locations with hundreds or thousands of interconnected computers. While worldwide networks connects hundreds of millions of computers worldwide, such as the internet. Another example of networks are the LANs and WANs. LANs starts for local area network and wide area network. These are the sizes. It actually varies greatly in terms of size of the area covered, number of users connected, number and types of services available, and area of responsibility. For a LAN, it is used as a network infrastructure that spans only on a small geographical area. It is only administered by a single organization or individual, and it provides high-speed bandwidth to internal devices. While wide area network is a network infrastructure connecting multiple LANs. It spans a wide geographical area, and it's typically administered by one or more service providers, while it provides lower speed links between local area networks. Also, we have the internet. The internet is a worldwide collection of interconnected LANs and WANs. LANs are connected to each other using wide area networks, while wide area networks may use copper wires, fiber optic cables, and wireless transmissions. The internet is not owned by any individual or group. The following groups were developed to help maintain structure on the internet. We have IETF, ICANN, and IAB. We also have intranets and extranets. An intranet is a private collection of LANs and WANs internal to an organization that is meant to be accessible only to the organization's members or other organizations or with authorization. An organization might use an extranet to provide secure access to their network for individuals who work for a different organization that need access to their data on their network. Both intranet and extranet is under the Internet. Building a network needs to have a reliable network. A network architecture refers to the technologies that supports the infrastructure that moves data across the network. And we have four basic characteristics that the underlying architectures need to address to meet user expectations. For a network to be reliable, it should have fault tolerance, scalability, QoS or quality of service, and security. A network that is fault tolerant limits the impact of failure by limiting the number of affected devices. Multiple paths are required for fault tolerance. Scalability, or a scalable network, can expand quickly and easily to support new users and applications without impacting the performance of services to existing users. As network designers, you should follow accepted standards and protocols in order to make the networks scalable. QoS, or quality of service, is the primary mechanism used to ensure reliable delivery of content for all users. Have you ever watched a live video with constant breaks and pauses? This is caused when there is a higher demand for bandwidth than available, and QoS isn't configured. With a QoS policy in place, the router can more easily manage the flow of data and voice traffic. The network security is one of the main issues specifically right now. There are two main types of network security that must be addressed: a network infrastructure security and information security. Network infrastructure security deals with the physical security of network devices, while information security is the protection of the information or data privacy of data transmitted over the network. Mainly, security has three goals. First is confidentiality. Confidentiality is only intended or when only intended recipients can read the data. Integrity is the assurance that the data has not been altered during transmission. Availability is the assurance of timely and reliable access to data for authorized users.